Welcome to my video of the multiplication of numbers. We're going to multiply 2-digit and 3-digit and 4-digit numbers. It's going to be great. At the end, I'm actually going to delve a little bit deeper into the why behind all of this, how all this works. I was recently showing somebody how to do this, and they said, well, why do you do this? And I thought that that was a really good question, and I'd like to give an explanation for that. But I'm going to start this off with the procedural things and how do you multiply numbers together. I'm going to assume for this video that you know how to multiply 1-digit numbers by 1-digit numbers, so you know what 7 times 8 is, for example. Okay? If you don't know that, we need to review some multiplication tables, and once you review those and you get a good handle on those, come on back and join us and we'll talk about multiplying larger numbers. And I'm going to show you how I learned it, and it's probably the way that most of you, if you're parents watching this video, learned how to do this. All right, there's an emphasis on this new math stuff, and I'm going to show you the bridge between what we learned when we were kids and what the new math is. I mean, it's all the same thing. You get the same answer in the end. But we're going to, like I said, when I delve a little bit deeper, we're going to look at the why and the how behind how all this works. But for now, let's just start with the multiplication of a 2-digit number with a 1-digit number. So what I'm going to do is I'm going to start in the bottom right here, and I'm going to multiply 8 by 7. Okay, forget about this 1 real quick. What's 8 times 7? We all know that's 56. So I put a 6 there, and I carry this 5. Now what I do is I multiply this 8 by this 1. So I start right and I work my way left. So 8 times 1 is 8. And then I'm going to add this 5 here. So 8 times 1 is 8 plus 5 is 13. And there's my answer. Okay? 136. Let's do 36 times 4. Same idea. I'm going to start with this 4. I'm going to multiply by the 6. And I'm going to keep moving my way left until I'm done. So 4 times 6 is, 4 times 6 is 24, so I put the 4 here and I carry this 2. 4 times 3 is 12, plus 2 more is 14. And so I get my answer of 144. So if you get the hang of that, then what you can do is you can multiply a 3-digit number, like 892, by 9. Okay, so what do? You take this 9, you multiply it by the 2, the 9, and the 8. You start right and you work your way left. So 9 times 2 is 18. Put an 8 there, carry the 1. 9 times 9 is 81, plus 1 is 82, so I put the 2 there, carry the 8. 9 times 8 is 72, plus 8 more is 80. Now you can see why knowing your single-digit multiplication table is really important. You should be able to see 9 times 9 is 81, 9 times 8 is 72. You need to know how to do that in order to do these larger problems, okay? So if you don't, that's totally fine. Maybe pull out some flashcards, maybe have somebody help you drill those into your head and your memory, and just get the hang of multiplying 7 times 8, 4 times 3, 9 times 2. That'll help you with these problems a lot further on down the road. And so then the question is, what if you wanted to multiply a 2-digit number by a 2-digit number? It's the same idea. So first, let's forget about this 1. Let's do the 4 times the 6 and the 5 like we normally would have if that were not there. So 4 times 6 is 24. So I put the 4 down, carry the 2. 4 times 5 is 20, plus 2 more is 22. All right, and now what I'm going to do is I'm going to move to this 1. Now this 1 isn't really a 1, it's a 10, because 14 is 10 plus 4. So remember how multiplying things by 10 works, right? If you multiply 7 times 10, well, that's 1 times 7, which is 7, and then you add this 0 at the end, right? So it's nice multiplying things by 10 because we just multiply the single-digit numbers and then put the 0 on the end, okay? Same thing with multiplying by 100. You just multiply normally and then add 2 zeros at the end. So I'm going to put a 0 down here as a placeholder because I'm going to multiply 56 by 1, which is actually really easy, and then I'm going to add this 0 on at the end to get 560. So 1 times 6 is 6. 1 times 5 is 5. I can go ahead and cross out this 2 because that was left over when I did 4 times 6. But at any rate, I'm going to add these together now. Okay, again, this 0 came from the fact that I wasn't really multiplying by 1. I was multiplying by 10. So 4 plus 0 is 4. 6 plus 2 is 8. 5 plus 2 is 7. And I get 784 as my answer. All right, so let's up the ante a little bit. A 3-digit number multiplied by a 2-digit number. It's the same sort of idea. We're going to start in the bottom right here with this 3, and we're going to multiply by this 3, this 6, and this 9. All right, so let's do that. 3 times 3 is 9. 6 times 3 is 18, so I put the 8 there, carry the 1. 3 times 9 is 27, plus 1 more is 28. So we get 2,889. Now I'm going to multiply by this 4. It's technically not a 4, it's a 40. So I'm going to multiply 4 by all this stuff up here, and then since it's really a 40, I'm going to add that 0 onto the end right there. I'm going to cross out this 1 because we've already used it. I should be doing math in pencil, as always. I should just be able to erase it, but pencil doesn't show up as well on the document camera here. 4 times 3 is 12. Carry the 1. 6 times 4 is 24, plus 1 more is 25. Carry the 2. 4 times 9 is 36, plus 2 more is 38. 38, Max. Now, you can see why using a pencil is important, but you can also see why keeping things in line is very important. If you get messy with this, because remember, we're about to add this together. If you get messy with this, you're not going to know, is this 5 being added to this 2, or what's in line with what, okay? You need to keep your 1s and your 10s and your 100s and your 1000s and your 10,000 spots all in line, so you can be successful and get the answer and celebrate every time you get the right answer. 9 plus 0 is 9. 8 plus 2 is 10. Carry that 1. 1 plus 8 is 9, plus 5 is 14. Carry the 1. 1 plus 2 is 3, plus 8 is 11. Carry the 1. 1 plus 3 is 4. And that is quite the large number. 41,409. All right, one final example, and then we're going to go ahead and jump into some of the theory that might help you with the new math if that's confusing you. So the first thing is, we're going to approach this problem just like we did the others. I'm going to start with the 4, multiply by everything up here, then move on to the 0, multiply everything up here, then this 3, multiply by everything up here, okay? So 4 times 2 is 8. 4 times 7 is 28, so I put the 8 here and I carry the 2. 4 times 4 is 16, plus 2 more is 18. Carry the 1. 4 times 1 is 4, plus 1 is 5. Now I move on to the 10s and I put a 0 there. Now here's the thing. First off, I'm going to cross off this 1 and this 2 because I've already used those. I don't want to confuse myself. But remember how multiplying by 0 works. 0 times 2. 0 times 7, 0 times 4, 0 times 1. Those are all 0. So really, I could write 0, 0, 0, 0 for all those, because 0 times all of this is 0. And now I move on to the 3's spot, this 3 spot right here, which is technically in the hundreds. And so when you multiply things by 100, you tack on 2 zeros at the end. Now you can see that perhaps this step right here of writing all these zeros really won't matter, because not only does multiplying things by 0 make a bunch of zeros, but adding zeros doesn't have any consequence. And so if you got a 0 right here, you could go, oh, you know what, there's no 10s, and so you could just skip this step right here and just put 2 zeros down for that 3 spot, okay, where the hundreds is. Okay, if you want to. If it helps you keep track of all this and put a 0 there and then do all this multiplication and then 2 zeros, that's totally fine. But just remember, you're really, when you're adding together, adding these columns, and if there's zeros in all these spots right here, you're just wasting pencil lead and precious mathematical ink. So 3 times 2 is 6. 3 times 7 is 21. Carry the 2. 3 times 4 is 12, plus 2 more is 14. Carry the 1. 3 times 1 is 3, plus 1 more is 4. And we add together. Okay, keep everything nice and in line. 8 plus 0, or 8 plus 0 plus 0 is 8. 8 plus 0 is 8. 8 plus 6 is 14. Carry the 1. 1 plus 5 is 6, plus 1 more is 7. Not a lot up here. That's a 4. A bunch of zeros plus 4 is 4. Put a comma right there. We get the answer, 447,488. So what is going on here? How does all this work? This goes back to the question that my daughter asked when I was showing her how to do this, she's like, why? Why do you do it this way? Why do you put zeros where you put them and all that? Now, the mathematical answer is the distributive property. So pretend A and B and C are whatever numbers you want. There's this property from math, and if you're not here yet in your mathematical careers, I promise you will be. And so that's why I think it's really important to go ahead and do this. There's something called the distributive property, which says if you have A and you multiply by B plus C, technically the order of operations says to first do this B plus C. Add these numbers together, and then do A times whatever that number was. The distributive property says, well, what you actually can do, if you want, is multiply that A and that B together. So A times B is whatever A times B would be. And then distribute this A over to this C as well. And you get A times C. And then we still need to add these together. And so these are equivalent expressions. You can do A times the sum of B plus C, or A times B plus A times C. If you remember this from algebra, great. If you don't, you will get here in the end, I promise. But here's the thing that the so-called new math is trying to get across to the students, is since all of our students are at some point going to be algebra bound and have to learn the distributive property, we're going to show multiplication through that way. Now, if you think back to the first example that I did, we had 17 times 8. All right? Now, I can write this as 8 times 17. Of course, we could write it in a row, not a column. And in elementary school, we learned how to break apart numbers like this. The number 17, that's really 8 times 10 plus 7. Now, the reason why you want to do that is because it's really, really nice multiplying things by 10. Because what you do is you do 8 times 1, which is 8, and then you throw a 0 on the end. And then you do, so what I'm doing here is I'm doing 8 times 10, and then I'm using my distributive property to do 8 times 7, which is 56. Okay? And then it's easy to add these two numbers together. You get 6 plus 0 is 6. 5 plus 18 is 13. So you get the answer of 136. Now, in my first example, that's what I got. So the reason why, to answer my daughter's question, the reason why you put zeros in certain places is because you're not really multiplying by 8 times 1. You're multiplying by tens. You need to take those placeholders into account. I remember one of my other examples was 9 times 892. We got the answer of 8,028. I want to again break this up and show you how the distributive property works. It's not just limited to adding two things together. This is going to be 800 plus 90 plus 2. Okay, so really it's 9 times 8, 9 times 9, 9 times 2, but we put zeros where appropriate. Again, this is 9 times the breakdown of 892, which is 800 plus 90 plus 2. Okay, and I can distribute this here, and this here, and this 9 over here as well. Multiply them together, then add them up. 9 times 8 is 72. Throw in 2 zeros at the end. 9 times 9 is 81. Throw a 0 in at the end because it's technically 9 times 90. And then 9 times 2 is 18. And we add these three numbers together. Now once you get to the level of adding three numbers together, you might want to put them in a column to keep your work in order so you don't lose yourself. So again, neatness is important. Keeping everything in line. The 1 spot, 0 plus 0 plus 8 is 8. The tens spot, 0 plus 1 plus 1 is 2. The 100 spot, 2 plus 8 is 10. Put the 0 there, carry the 1. 1 plus 7 is 8. We get the same answer. So the why and the how behind all this works. It all has to do with the distributive property. And it's the reason why you put zeros where you need to put zeros. Now there's one more version of the distributive property that I'd like to talk about. And that's if you have two things added together, and then two things added together, and then you want to multiply those two different sums together. So this is what we call in algebra the FOIL method. Okay, that stands for first, outer, inner, last. And that is how we multiply the two-digit number times the two-digit number, and I'll get to that in a bit. But what the FOIL method says is multiply the first things in these sums. F stands for first. So A times C is A times C. right? We don't know what these numbers are. That's sort of the essence of algebra, is you actually don't know what A and C are. But we can manipulate them algebraically. We can sort of arrange them differently according to certain rules and properties, such as the distributive property. So the O stands for outer. A is on the outside, D is on the outside. So I'm going to do A times D. I stands for inner. The inside bits are B and C. So B times C. And then L for last. B is the last one here. D is the last one here. So I do B times D. And to finish this off, I add all of these together. So that's the distributive property. Sometimes you'll see it like this. AC plus AD plus BC plus BD. All right. Oftentimes when we multiply things like this together, we put them together. So instead of putting the little X here for multiplication, the little cross, we just put A and C together, signifying that these are being multiplied together. Okay, same thing for AD, BC, and BD. All right, so why am I mentioning this? Well, I wanted to delve a little bit deeper into another problem that I did before. So earlier I used the old school method to multiply 56 and 14. The new math method, or this way of breaking things up and using what's called the distributive property, is of utmost importance. Because here's how I'm going to think about this problem. I'm going to write 56 as 50 plus 6 and multiply that by 14, which is 10 times 4. And again, the reason why you want to do that is it's nice multiplying things by 50 and 10, things that end in zeros, because you multiply their single-digit components together and then just throw however many zeros on at the end. For example, if I wanted to FOIL this out, I do first, F for first, 50 times 10. That's really easy because that's 5 times 1, which is 5, and then I put 2 zeros at the end. O for outer, that's 5 times 4, which is 20, but I didn't multiply by 5, it was actually 50, so I need an extra 0 at the end right there. I stands for inner. The inner components are 6 and 10. 6 times 10 is 60. L for last. 6 times 4 is 24. And so to get my answer, I just need to add these numbers together, and these numbers have zeros in a lot of convenient places, and so it's not going to be too difficult. What I do need to do, since I have a lot of addition, is I'm going to put them in a column so I don't lose myself and get too sloppy or messy here. So I'm going to put everything in line up my ones position, line up my tens, my hundreds. That's a bunch of zeros plus 4 is 4. A bunch of zeros plus 6 plus 2 is 8. 5 plus 2 is 7. So we get the same answer that we got using the old school method. Again, why does my student have to learn this breaking up of numbers and all this when we can just multiply it like we did back in the 80s and 90s? And the answer to that is, at some point, your student is going to use the distributive property in algebra. If we can get them thinking about this stuff right now, breaking 56 into 5 and 6, or 50 and 6, breaking 14 into 10 plus 4, and I made a mistake here, this should be plus 4, not times 4. If we can start students thinking about this stuff early, then when they get to algebra, this concept hopefully won't be as intimidating or confusing to them. So I can't let you go without giving you some practice problems to work on. So as always, these are going to have answers in the description of this video, but I strongly recommend that you do these first, give them a shot, practice, 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 maybe even practice these problems both ways, doing it with the old school method here like I started with, and then the new math method where you break it up and use the distributive property. However you do it, make sure you do these on your own first, and then click on the description to see if you got them right or not. We'll get the answers down below. Thanks for joining me. Hope you enjoyed this video. Hope you learned something. Join me next time. We're going to have a bunch more videos. Like, subscribe, tell your friends. Thanks for watching.